Hi everyone, I am Weiyi, PhD student from the University of Manchester. I am honored to present an ongoing study, an assessment practice of customer service chatbot from Chinese governments based on benchmark testing. This study is also credited to my excellent co-authors, Yuting and Futian from Peking University. We are probably all familiar with ChatGPT. We input the question and it answers. I believe many of us have been exposed to such an online question answering tool, though mostly these Q&A systems are not so powerful as ChatGPT. Actually, artificial intelligence question answering has emerged as one of the critical applications across diverse industries. Of course, the public sector is certainly not behind this trend. Within the field of e-government, question answering systems, also called chatbots, serve as intelligent customer service agents that leverage natural language processing technology. The public sector around the world has begun to adopt the customer service chatbot to provide services. At least in China, we notice over 25 official government websites have launched this kind of chatbots. They are expected to address queries, provide policy consultants, and facilitate business transactions. However, the performance of these chatbots varies on Chinese official government websites. Common issues are like the information may lag, and the chatbot cannot understand the input or give irrelevant answers. And we also notice a gap in the construction of customer service chatbots by local governments. Therefore, we need an approach to standardize the development of government customer service chatbots. Naturally, the first step we should know is how well these chatbots perform. So we propose the research question here: how to assess the performance of government customer service chatbots. Specifically, we want to know to assess what aspects, to use what methods, and whether it is feasible. Therefore, our study presents a performance testing approach for customer service chatbots in government, grounded in benchmark testing. We hope this approach can also serve as a valuable reference for global e-government practices. Well, before heading to our outcomes, I would like to briefly talk about what we see in existing studies. There are several experimental studies assessing government chatbots through various approaches, mainly including technical usability testing, user satisfaction assessment, and simulated user experiment. But these approaches are more or less subjective or lack sensible standards in the government application context, or the scale of the assessment may be limited. So we turn to the benchmark test. This approach shows advantages such as measurable, transferable, etc., thus being more general and objective. It has been widely applied in many fields, including business chatbot performance assessment. But it still remains to explore how to apply it in assessing government question answering systems. Then I will hand it over to Yuting. Yuting.
Hi, Weiyi. Hi, Weiyi.
Hi.
Thank you, Weiyi. I am Yuting, postdoctoral fellow from Peking University. Our study contains 3 parts. First, we construct an assessment index framework from the literature and practical lessons. Then we design the assessment procedure and build the tool according to the index, and then put it into practice to test some Chinese government customer service chatbots. Next, I will explain each part. Based on the D&M Information System Success Model, we built an assessment framework. It contains 3 dimensions. The first one is technical capability. It refers to the ability of the chatbot to perform the question answering function. It determines whether the chatbot can accurately recognize users' questions. The second dimension is on its knowledge reserve, which refers to how well the chatbot knows relevant information about government affairs and services. It is important because the chatbot relies on its knowledge to give effective answers. And the final one, we name it as the situational application dimension. It is here to assess whether the chatbot can integrate its knowledge and capability well, thus providing consistent response in variety scenarios. Each of these 3 dimensions contains several detailed indicators. For example, under the technical capability dimension, we have 3: understanding ability, associative ability, and reasoning ability. Under the knowledge reserve dimension, we have policy, management, and administrative knowledge. And we also chose 7 scenarios to assess the chatbot's performance. So let's move on to the assessment procedure. The first step is to formulate the benchmark test set. Here we go through 3 phases. The first one is data collection. Regarding the test context, we consider 3 aspects. We would like to ensure they are diverse and rich, and they have to be accessible. So in practice, we require the frequently asked questions from government portals. Next, we screen, clean, remove duplicates, and rewrite this data, thus formulating the question set. Regarding the answer set, we apply the principle of minimum necessary keywords to set answers. These keywords are from our self-built program. It segments words of collected responses and calculates frequency. Then we manually check the answers and do a robust test. Finally, we get a preliminary benchmark test set for the Chinese government customer service chatbots, which has 1,183 questions in total. We can see numbers in each bracket behind the indicator. We hope to expand the test set in the future as we develop it into a mature tool. It's not enough with the test set. We also need the scoring criteria. Here we apply a simple weighted summation to score the tested chatbots. We can see the formula on the top. We will not introduce it to you in detail, but I have to explain how we define this weight and valid response. We use the chopping weight method to get the weight of all indicators. The entropic weight method, in a word, is to determine the weight according to the degree of value dispersion. Regarding an indicator, the smaller its information entropic is, the more dispersive it is, and the greater it is influence on the comprehensive assessment, which is a weight, but it is an objective weight method. Therefore, we can avoid the bias caused by human factors. This is also one way where our assessment approach is more advanced. And in terms of the valid response, it means the response should contain all minimum necessary keywords. Here you can see the two formula of the entropy weight method. The first is how we calculate the information entropy. And the second is how we calculate the weight from the information entropy. In practice, we randomly select 20 questions from each indicator to calculate entropy weights. And the weights finally decide how many test questions are extracted from each indicator. On this slide, you can see, for example, under the technical capability dimension, the associative ability influences more to the final score. But the test processes, it means go through 3 steps. The first is to select assessment objects. In practice, we choose 29 provisional level government customer service chatbots to assess. They are comparable because they are at the same administrative level and offer similar basic services. Then we need to set specific weight for all indicators. Here we appoint each valid response point 0.1 point. Then sum it up and finally carry out the assessment. And the last part, we practice the assessment and score the provisional level government chatbot in China. Here, I would like to introduce some of our preliminary findings. First, we see a significant correlation between the quality of government chatbots and the local economic level. Higher GDP, better government chatbots. But we don't see a significant correlation between the quality of chatbots and the local population scale. However, from the administrative perspective, it costs more to serve more people manually in the case of ensure the quality of service. It is necessary to introduce the intelligence question-answer system to supplement manual service, thus reducing labor costs. We also see a weak correlation between the quality of chatbot and the salary level. The result indicated that higher income people do not require that much of the local government to provide a higher quality of intelligent question-answer service. Okay, thanks. Next, I would like to share. Let's turn to Weiyi.
Thank you, Yuting. Our work largely relies on our self-built platform to collect and process data. It is open access now, and we welcome all scholars interested in intelligent government service to use it. In the end, we pretty thank the Research Center of Public Policy, Laboratory for Government Big Data and Public Policy, Peking University, for supporting this work. We would also like to thank 3 students for their help, and thanks for the support of the Center for Digital Development, University of Manchester. Thank Data for Policy 2024, and thank you for watching.